at this example. Without graphing. So yesterday we were working on graphing our parabolas. We talked about how just picking points is really not beneficial. It just takes too long and we may not be very accurate. We talked about if it's written in vertex form, we can do transformations. But if it's not, what formula did I give you to find the vertex? Okay, x equals opposite of b over 2a. And so we use that in order to get our graphs. Now I'm asking you a question. Without graphing, locate the vertex and axis of symmetry. Do I have to have the graph to find the vertex? No, we just have to know x equals the opposite of b over 2a. What is my b value? 6. So I have the opposite of 6 over 2 times negative 3. So negative 6 divided by negative 6 is 1. Is that my vertex? No, vertex is an ordered pair. So how do we get the y value? Okay. 3 plus 6 plus 1. So. All right, so my vertex is the point 1, 4. What is my axis of symmetry? Good. Remember that I wanted that full equation. X equals. Okay. Can you tell me, just by looking at the equation, if this parabola would open up or down? Why? Alright. The negative a makes it open down. So, can you tell me, is that vertex, is that a maximum or a minimum point on my parabola? Maximum. If it's opening down, that is the highest point of our graph. Alright, is that okay? I have a couple more of those. I don't know if we really need to do all of them. Why don't you guys try C? We'll skip B. You guys do C. So, vertex and axis of symmetry. Tell me if it opens up or down. Okay, so opposite of B will be positive 4 over 2 times negative 8. We get negative 1/4. Plug that in. Negative 1/4 squared equals 16. So you guys have calculators in your hand. I'm sure you did this faster. So what do we get? Okay. What you guys said? Okay, so my vertex is the order pair negative 1/4. All right. Axis of symmetry. Equals negative 1/4. Does this open up or down? No. All right. Are we okay with that stuff? Okay. Second thing I want to talk about today is the discriminant. So, remember back, like solving quadratics, right? Sometimes things factored nicely, and you could solve like quadratic equations by factoring. If not, you'd use the quadratic formula. Just remember that. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is a part of that. It's just the b squared minus 4ac. So it comes from the quadratic formula. But all it is the part under the radical. It doesn't even include the radical. So the discriminant is just that b squared minus 4ac. All right, and that number actually tells a little bit about the type of what our graph will look like. If that number is positive, okay, then we are finding solutions where our graph is equal to 0. Okay, where a graph is equal to 0, that's the x-intercepts, right? So if this is a positive number, I have something plus that, something minus that, I get two different x-intercepts. So in terms of my graph, that means that when I go to graph it, it will have two x-intercepts on our graph. Right? It's two real solutions, so we get two places where that graph would hit the x-axis. If you do b squared minus 4ac and you get 0, then if you take something plus 0 and something minus 0, what's true about those numbers? It's the same. So I get one answer out twice, right? In terms of my graph, that means it hits the x-axis once. So it would only be one x-intercept. Okay, if that discriminant is negative, if you have a negative under a square root, what kind of numbers do you get? Imaginary. When we graph on an xy axis, are we graphing imaginary numbers? No. So how many times do you think that hits the x-axis? 0. So if you know the discriminant, you know a little bit about your quadratic. If it's a positive, you hit the x-axis twice. If it's 0, you're looking for something that hits the x-axis only one time. And if it's a negative, then your graph never hits the x-axis. Okay, so that's just a little bit of connection between the discriminant that we've mentioned before and what it does on the graphs of these. Any questions there? Okay, I'm going to have you guys pull out your books now, or at least one for every couple people, so you guys can look at one. I want you to turn to page 313, and we are going to do problem 37 together. Okay. So we should be looking at a graph kind of like this. And our directions tell you to find a quadratic function that matches this. In other words, we're trying to write the equation for this. Right? There are different options for how to do it. But let's kind of relate it back to yesterday. We talked about, with our quadratics, the vertex formula. So look back in your notes if you need to. I think it was like the box on the front page or something. What was the vertex form?
X equals a times x minus h squared plus k.
And it said HK was the vertex, right? So if I look at this, what is my vertex? 2, -1. So if I put that into my formula, I don't know this A yet, x minus the x value of my vertex was 2 squared plus k, so plus -1 would just be a -1. So I just took my vertex, plugged it into the HK. Is everybody with me so far? Okay, the only thing that's left is I have to figure out what this A value could be. So we're going to use another point on the graph to help us. It can be any point in the world, as long as we can tell for sure. So let's go with this one. That point is 0, 0. So that means y equals 0 when x is 0. Okay, 0 minus 2 is -2. -2 squared is 4. Can you find the A value now? Add 1, divide by 4. So my A is 1/4. So now I know my full equation is 1/4 times x minus 2 squared minus 1. So I just use the vertex and one other point to figure out what A had to be. Questions on that? Should we try another one of those? Why don't we flip the page and do problem 39 together? So if we look at that graph, so if we're trying to do our f of x equals a, x minus h squared plus k. What is the vertex of this? So if I plug that in first, be x minus 1 squared plus 4. Now I have to find out what my a value is, so how do I get there? Use another point. So the other one that it's clearly marked for us in our picture was 0, 2. So f of x, that's the y, so that was 2, equals a times 0 minus 1 squared plus 4. 0 minus 1 is -1. -1 squared is 1. 1 times a. Subtract over the 4, and a is -2. Does it make sense that a would be a negative here? Why? Because it opens down. The last thing I want to talk about is vertical motion. This is something that, without a graphing calculator, a lot of these types of questions I probably wouldn't be able to ask you on a test. But they show up on ACT sometimes, so I don't just want to skip over it. So I thought I might kind of show you one and talk about it a little bit, and then I'm done. I'll give you guys time to work on it. Okay? So vertical motion, you might have seen this formula like in physical science or physics before. We know that in general, if we have a quadratic, the vertex tells us our maximum or minimum. Height of an object can be measured by this equation. The -16 is actually due to gravity, so that's always a constant. T is representing time. V sub 0 is like your beginning velocity or initial velocity. How much speed did you start with? H sub 0 is your beginning height. What height did you begin at? And the entire thing is giving us our height at a given point in time. Filled in. So let's take a look. I don't know. How many examples did I put on this one? Did I just do one? So one with multiple parts. So we'll go ahead and do just this one. I had some more, but I'm only going to do one for you. So a ball is thrown directly upward from an initial height of 75 feet with an initial velocity of 112 feet per second. Give a function that describes the height in terms of time t. So we know our function, S of t is vertical motion, that's our height. We have 16t squared plus v sub 0 t plus h sub 0, that's what we just wrote down. All you have to do is replace the v and the h. V sub 0 is our beginning velocity. How much speed did we start with? 112. H sub 0, what height did we begin at? 75. Okay. Part B. This is the type of question that I could still very well ask you on a test. After how many seconds does it reach its maximum height? Anytime I ask you about a maximum or minimum of a quadratic, what am I asking you for? The vertex. Can we find the vertex of this? Absolutely. So my variable here is time, so it's like t equals the opposite of b over 2 times a. So you get negative 112 over negative 32, or 3.5 seconds. Okay. If I said, what is the maximum height, what would you do? And we get maximum height is 271. Those are the only questions I could really ask you because all the others require a graphing calculator. If you guys are interested, I can show you how to do them, but I'm not going to put anything like that on a test. So do you want me to show you some information about your graphing calculator, how to find certain things, or are you good with today? Anybody just super curious? Okay. I'm going to go ahead, I'll show just as a little tidbit for those of you that want to see, and then I'm done. Okay, so people want to know. Come on, you want to learn. This is fun. Learning is fun. Oh, come on. Okay, so we'll learn another way of doing this later on, but I'm asking when the height is above 200, and just as like ACT type question, they would probably give you one that could be solved without a calculator, but your calculator would make it easier. If you go to your y equals, so grab a graphing calculator if you don't have one. We're going to type in our original equation, but you can't use t, you have to use x. So negative 16x squared plus, what was it, 112x plus 75, thank you. And I'm going to go and do one more thing. I want to know when it hits a height of 200. So I'm going to go to y2 and type in 200. Okay? Now, if you just look at your graph right now, you're probably not seeing anything because our normal window goes from negative 10 to 10. So I'm going to go into my window. I'm going to go down, change my y max. I know I want to be greater than 200, so maybe I'm going to go to 250. And under that, my y scale, I'm just going to change that to 10, and that will speed my calculator up a little bit. It's going to count by 10s. So then if you look at the graph, there's the path of my object. There's when it hits a height of 200. If you want to find where those things meet, which is a very useful thing, your calculator can do it for you exactly. So if you go second, trace. If we're trying to find where two things cross, what do you think I'm looking at? Intersect, number 5. Okay, your calculator does this part for you. It says first curve, and if you notice up the top, it has the first equation. So we're just going to say yes, that's what I want you to use. so hit enter. Then it says second curve, and it switched to the 200. Say, yep, that's what we want, hit enter. Now, these graphs technically go on forever. We're looking at a snippet of it, but you have to tell your calculator where to look, so now it asks for a guess. So you just get close to it and hit enter. This is a really good technique on the ACT, even if it's not something like this. If you need to find when two things meet, you can graph them and ask your calculator to find the intersection point. And so I see they meet when my x is the 1.39. And so then, if you want to find the other one, you just have to repeat that. So you go second, trace, intersect. First curve, just hit enter, second curve, hit enter, and then you can move over to get your next point. Enter. And so it tells us that intersection is at 5.606. So between 1.39 seconds and 5.61 seconds, my height is over 200. The last one is asking where it hits the ground. So that's like, you could do it several different ways. You could do the same thing, just finding when it has a height of 0 and go through the same process. So, fun little graphing calculator tidbit that I know you all appreciate, even if you didn't know you wanted to learn that. All right. So yesterday I gave you this part of the assignment. Today I'm adding these problems, and you have the rest of the time to work. It's all due Monday, but a lot of these are magic, so it should go fairly quickly.